differential equation. So m dx plus n dy, this is reduces to exact differential equation. That exact differential equation, again, how we are writing into the form of m1 dx plus n1 dy is equal to 0. And again, you have to check whether this is exact or not. Okay, so if it is an exact differential equation, then you can find a solution. So here the solution is integral m1 dx plus integral n1 dy is equal to c. On m1, to take y as a constant. On n1, the terms free from x. So terms are free from x. So this is the way to find a non-exact differential equation general solution. So first check the given differential equation, whether the given differential equation is exact or non-exact. So if it is a non-exact, you just find out an integrating factor. Multiply that integrating factor to the given differential equation. So that differential equation reduces to the exact differential equation. So after that, writing a general solution, the formula is integral m1 dx plus integral n1 dy is equal to c. This is the formula to finding a solution of a non-exact differential equation. But here, the finding and integrating factors are the different. So the process of the solutions is the same in all the rules, but finding an integrating factor is a different. So this is the rule 1. And next is see the rule 2. So next rule 2 is the given differential equation is m dx plus n dy is equal to 0. So this is also in the form of y into f of x comma y dx plus x into g of x comma y dy is equal to 0. So if the given differential equation is of the form, then what is the integrating factor?
1 by mx minus ny.
Right, 1 by mx minus ny is an integrating factor. Now multiply this integrating factor to this differential equation. This differential equation reduces to the exact differential equation. And after that, find the general solution. Already we know how to find a general solution for exact differential equation. Use that one and then find out the general solution for the non-exact differential equations. And next is the rule 3. So rule 3 and rule 4 is somehow is the same. So only the difference is the 1 by n and minus 1 by m is the difference. Rule 3 is dou m by dou y minus dou n by dou x divided by n. You just find out the partial derivatives of these two and first subtract these two. So after doing the subtraction, once observe the function. So after observing the function, you think about the given differential equation. So which function is suitable to divide for this? Which function is to divide for this dou m by dou y minus dou n by dou x? So take that function and divide with that. So that division value must be a function of x only. Must be a function of x only, or only the constant, or only constant. So then here, what is an integrating factor? Integrating factor is here e power integral f of x dx. So e power integral f of x dx is an integrating factor if dou m by dou minus dou n by dou x divided by n. For rule 4 is minus m by minus 1 by m. We are dividing with that minus 1 by m. See the rule 4. There is not the here the rule 4 is here. I am writing the rule 4. So dou n by dou x minus dou m by dou y divided by capital M. So this is equal to function of y only or the constant. Then this one also you can write this as or dou m by dou y minus dou n by dou x. So you just put in the bracket whole divided by minus m I am writing. So if I am writing the minus m, so minus m. So if you observe the rule 3 and rule 4, numerators are the same and the denominator is n here, denominator here it is a minus m. So this is the function of y only if you will get all the constants. Then the integrating factor is here. The integrating factor is e power integral f of y dy. E power integral f of y dy. So this is an integrating factor. Now multiply this integrating factor to the given differential equations, and after that do the solution for the exact differential equation after multiplying an integrating factor. So these are the different rules to finding an integrating factor and finally finding a solution for the non-exact differential equations. And now we'll see the applications. So here we have the two applications are there for first order and first degree differential equation. So first one is a Newton's law of cooling. So Newton's law of cooling. So Newton's law of cooling states that the rate of change of temperature of a body, is proportional to the temperature of a body. Difference between the temperature of your body and that of the surrounding medium. The statement is rate of change of temperature of your body is proportional to the difference between the temperature of your body and that of a surrounding medium. So mathematically we are writing d theta by dt is proportional to theta minus theta naught. So usually we are taking the theta naught is the surrounding medium temperature. So surrounding medium temperature is usually air we are taking. Okay, usually air. So here we are taking a proportionality constant. Why we are taking the proportionality constant here? It is we have to solve this differential equation by taking an the proportionality constant. So minus k you have to take minus k into theta minus theta naught. Why we are taking the minus k? So we are solving here all the problems or the cooling cases. So cooling means a decreasing problems only we are doing. Okay, so for that we are taking the proportionality constant as a minus k. So after solving this, theta is equal to theta naught plus c into e power minus kt. So theta naught plus c into e power minus kt is the equation. So this equation or this one gives the temperature of a body at any time t, or you can also the time. So at any time you can find out when the temperature gives. Okay, so this formula is a very important formula to find the Newton's law of cooling. That means to find the temperature of a body or the time we can find out. That is complete. And here the c and k are the arbitrary constants. So these two arbitrary constant values also we have to find out. Then how can we find out these two arbitrary constants c and k is how can we get the c means from the initial conditions. So initially theta t is equal to 0, theta is equal to some theta 1 you can choose. So from this you can get the value of the c. So after that again another conditions also they will give. So what is that another conditions? So some t they will give some 10 minutes or the 12 minutes like that. So in that cases the temperature of the theta is equal to some theta 2 value it will give. Okay, so then we have to get the value of the k. So you will get the k value. Okay, k value you will get. So after getting the k value you can find out. So substitute this k value and c value in this function. So theta is equal to theta naught plus c value you can put it here, and e power minus k value you can put it here. Okay, then the equation must be in terms of the theta and the t. So already we know the theta naught value. So this theta naught value also they will give in the question. So from the question you can take the theta naught. Theta naught is the temperature of the surrounding medium air. Okay, that is the air temperature we are taking. So after that we will get the theta. So if they will give the time, you have to find out the theta. If they give theta, you can find out the time. So this is the Newton's law of cooling. And next is the law of natural growth or decay. Natural growth or decay. So natural growth or decay. So here the statement of the natural growth or decay is rate of change of a quantity is proportional to the quantity present at any time. So mathematically we are writing dn by dt is proportional to capital N. So this capital N indicates this is the quantity. This is the quantity and this is the time. So this is the time. So natural growth or decay. So two cases are there. The first one is the growth. The second one is a decay. So if it is a growth, if the problem is in growth, then you have to take the proportionality constant as a plus k into n. So after solving, you will get the equation is, so n is equal to c into e power kt is the solution. And next is the decay. So dn by dt is equal to, we are taking the proportionality constant as a negative. So decay is the decreasing cases. So growth is the increasing cases. So after solving, so you will get the equation is n is equal to c into e power minus kt. So these are the two different formulas for the growth and the decay. For growth, you have to take n is equal to c into e power kt, and for decay, n is equal to c into e power minus kt. Then how can we identify whether the given problem is for growth or for the decay? Means you just observe the given values in the problem. If the values are decreasing, so if the values are decreasing, then you can consider that is for the decay. So if the values are increasing means time, already we know the initially time t is equal to 0. So n is equal to some 200 they will give. So within the 20 minutes, so it is 100. See here time is equal to initially 0. In 20 minutes n is equal to 100. So from 200 to 100 means this is a decreasing. So if it is these values are decreasing, you can use this formula. So if it is a increasing, so t is equal to 0, n is equal to some 300. So within the 12 minutes, the n is equal to is 600. So here, see observe the values of n. So from 300 to 600, it is increasing. So these are the increasing cases. If it is increasing cases, then take the formula of the growth and then find out the solution. Okay. C and K are the arbitrary constants. So this C and K we have to find out first, and later we have to find out the n value when T gives. So when T we have to find out when n gives. So when n gives, you have to find out the value of the t. So this is the law of natural growth or decay. And next is the higher order. So linear differential equation with the constant coefficients. So in our syllabus, we have only constant coefficients. English plus.
Okay.
With the constant coefficients. So here the differential equation of the form d power n by dx power n plus p1 into n minus 1 the derivative plus p2 into n minus 2 derivative of dy by dx plus and so on, p and y is equal to q of x. So we have to find the general solution of this higher order differential equation, but here the degree is the 1 only. Degree 1 order is more than 1. Order is more than 1. So order is more than 1.
Beautiful, ugly, easy, difficult, full, empty, good.
So this one we have to convert into the operator capital D. So capital D is the differential operator, and the 1 by D stands for the integration. So D is equal to d by dx, d square is equal to d square by dx square, and so on. Okay. So now we have to substitute this into the form of this equation. The first equation, d power ny plus p1 into d power n minus 1 into y plus and so on, P and Y is equal to Q of X. P and Y is equal to Q of X. So this one also, this one we have to write into this form. So d power n plus P1 into d power n minus 1 plus and so on, Pm into Y is equal to Q of X. So here, this is in the form of f of d into Y is equal to Q of X. So here we have the two forms are there, f of d into Y is equal to 0 and f of d into Y is equal to Q of X. So I'll give one question to you. Wait, I'll give you. So I'll give one quiz.
Hard. Hard. Is hard. Oh, genius. Oh, genius. Genius. Okay. Genius. Surveyor. Oh. అలా ఉంటేనే ఆకలి చేస్తా ఆకలి ఉందా beautiful ugly easy difficult and big good bad fat thin heavy light heavy light okay no beautiful ugly అమ్మా లాస్ట్ 10 minutes క్వశ్చన్ ఏఎన్ క్వశ్చన్స్ లైట్ Jaya.
Yes, once you see the chart box. So please answer it fast. Please give your quick answer quickly. Give response quickly. So no option in. Wait, I'll change. Wait. But don't do that. I will send another link to you. So that one you will do it. So use the second link. Use the second link and give your response. So please give your answers. Okay, till now I got only 4 responses. Only 5. Till now 11 members are attempt. Out of 11 responses, only one student has given wrong answer for the first question. The second question is out of 12. Just now I got the 12 responses. Out of 12, only 8 responses are correct. Okay. So only 14 responses. Please give your respond quickly. Please respond quickly. So yes, roll number 5. 5 has given one mistake. Roll number 5, 17. Roll number 17 got 0 mark. And 5, 1, 17, 0. 29 got only 1 mark. 14 and 31 got 1 mark. And 61 got 0. 36. Okay, 36 is 2. Roll number 5 again 1. 5, 1. Next roll number 18. 18 also 1. 11 also only 1 mark. Still now I got only 32 responses. So out of 32 responses, 93% of the students has given the first question has given the correct choice, 93%, and the second question. In the second question, out of 33,
Yes.
33 responses, only 72% of the students has given correct answer. Correct answer they chose. Only 24 students they chose the correct answer. So people, the 3%, 9% of the students, right? 73, right? 34. So only 34 responses till now I got. Only 34, but here, see here. The solution of this is, so f of d into
I
f of d into y is equal to 0. For this type of the differential equation, y is equal to the complementary function. So for f of d into y is equal to q of x. So for this differential equation, the general solution is a complementary function plus particular integral. So both you have to find out when q of x function is included in the given differential equation, f of d into y is equal to q of x. Q of x is the differential equation. Okay, f of d into y is equal to 0. The solution of this is y is equal to only complementary function. So this is only complementary function. So if f of d into y is equal to q of x, you have to find out the both complementary function and a particular integral. So how can we find out the complementary function? So that is completely depends on the roots. So how the complementary function? So this is the given differential equation of the form is f of d into y is equal to 0. You just substitute, put d is equal to m in d is equal to m in f of d. So that is the auxiliary equation. So auxiliary equation means the algebraic equation of f of m is equal to 0. Algebraic equation of f of m is equal to 0. Put d is equal to m in f of d. So that is reduces to f of d. F of m is equal to 0. So this is the polynomial of degree n. So which is a polynomial of degree n. So degree n means, so that degree n means we will get the n roots. So that n roots, how we are taking m1, m2 and so on mn. So these are the roots of the given differential equations. So roots are the different types. So see the different types for the different function for that. So first is m1, m2, m2 and so on mn are the real roots. So if it is a real roots, what is a complementary function? What is a complementary function if m1, m2? So all the roots are the different. So c1 into e power m1x plus c2 into e power m2x plus and so on cn into e power mnx. This is the complementary function. So if two roots are repeated, the first two roots are repeated, the remaining all are real and different. So then the complementary function is, so first write the complementary function for the repeated roots. So for the repeated roots, you have to take the complementary function of c1 plus c2x into e power m1x plus c3 into e power m3x plus and so on cn into e power mnx. Right? And next is the three roots are repeated. The remaining all are the real and different. Then the complementary function is a c1 plus a c2x into c3x square into e power m1x plus a c4 e power m4x plus and so on plus a cn into e power mnx. So these are the complementary function for the real roots. So different real roots, repeated roots, two times repeated, and 3 times repeated, then how can we write the complementary function? So if it is 3 times repeated, you have to take constants c1, c2, c3 along with the terms of the x, along with the x. First you take the 1, next you take the x square. So if it is a 4 times repeated, you have to take the 4 arbitrary constant c1, c2, c4 along with the variables is the 1, x square and x cube. c1 into x plus c2 into x plus c3 x square plus c4 x cube into e power m1 x. So remaining you write as a real and different. If it is a real and different, you have to take only the single constant, arbitrary constant along with the exponential power. Right? This is the roots for the real. And next is the complex roots. Sometimes it is a complex roots also. So that complex roots you can choose it as a alpha plus or generally we are taking alpha plus or minus I beta. Alpha plus or minus I beta and remaining are the real and different. So you can write the complementary function for the complex root. So e power alpha x. So first you write for the complementary function complex number. E power alpha x into c1 cos beta x plus c2 sin beta x plus remaining or the real and different. Already the two roots are covered in the in complex number. The remaining is the C3 e power m3x plus n7 en e power mnx. So this is the complementary function for the complex root. So complex root is also repeated twice sometimes. So alpha plus or minus I beta. So then now it starts with m5 and so on. So e power alpha x into c1 plus c2x cos beta x plus c3 plus c4x into sin beta x plus the c5 e power m5x plus and so on plus cn e power mnx. So this is the way to write the complementary function for the complex roots. So if it is the third roots are there, you include here the hyperbolic function. So C1 cos beta hx, C2 sin beta hx. If it is a third roots or there, already we know the how the third roots is under root. So if the under root involves, so alpha plus root beta plus or minus root beta. So these are the third roots. So for the third roots, we have to take the hyperbolic functions instead of the trigonometric functions of the cos beta and the sin beta. So this is the complementary function. And now see the particular integral. How can we find out the particular integral? So here we have the different cases are there. So actually, how can we general procedure is the general formula of the particular integral is f of d into f of d 1 by f of d into q of x. So this is the formula of a particular integral. So the general process to find the particular integral is first take the 1 by f of t. So use the partial fractions, use the partial fractions on this 1 by f of t. You can split into like this f of d, that means 1 by d plus a, or so whether it is a plus or minus, just simply I'm writing. So plus 1 by d minus a. So d minus a into q of x. So into q of x. So you have to multiply q of x with each of this term and use the formulas of 1 by d plus a into q of x integral 1 by d minus a into q of x. So this is equal to e power minus ax into q of x into e power ax. So this is e power ax into integral q of x into e power minus ax into dx. So this is the main exact actual user to find a particular integral. So using always this is the very lengthy process. So that's what we are using the different cases to find the particular integral for the different functions. See those for different functions. So first rule one is, so case one is a q of x is equal to e power ax. So if q of x is e power ax, so particular integral is 1 by f of d into e power ax. So what we have to do in this is you just substitute d by a in f of d. So where f of a is not equal to 0. So if f of a not equal to 0, so that 1 by f of a into e power ax is a particular integral for f of d into y is equal to e power ax. Suppose sometimes f of a is
Simila
equal
etla
to
ra.
0 also we will get. So if f of d is equal to 0, yes, 55. Please mute yourself. 55. Right. Thank you. So now, if sometimes f of a is equal to 0, we will get. So what we have to find out, or how can we find out the particular integral if f of a is equal to 0 and x into 1 by, you have to do the differentiation in the denominator with respect to d, x into 1 by f dash of d into e power ax. And later you substitute again d by a here. So where f dash of a is not equal to 0. So if f dash of a is equal to 0, so you have to take in that case x square by 2 into 1 by f double dash of a into e power ax. Since f double dash of a is not equal to 0, f double dash of a is not equal to 0. So this is the rule 1. Rule 1 is different. So for every rule we are having the substitutions or the doing the procedure is different. So don't apply all the functions as a single rule. So rules are different. So doing the procedure is also different. Rule 2 is f of d is equal to, not f of d, q of x. So q of x is equal to sine ax r cos ax r cos of ax plus b or sine of ax plus b. One by f of d into q of x. So here the q of x is a sine ax or any four of this function. So if it is the sin x is there, so in the place of this f of d, we have the d square term is there. So you can write f of d square into sin ax. So you substitute in the place of d square by minus a square into sin ax. So d square is equal to minus a square. This is not minus a whole square. Only you, this is square only for the term a only, not for the negative. So minus a square sin ax. So only if f of minus a square is not equal to 0. F of a square is not equal to 0. Suppose if f of a is f of minus a square is equal to 0, what you have to, how can we find out the particular integral is 1x into 1 by f dash of d square into sine ax. Again substitute d square by minus a square. So only here we are substituting in the place of the d square is equal to minus a square. So not in capital D. So we are not substituting in the capital D. Sometimes in the denominator, the D term also must included. So if D term is there, then how can we do? How can we substitute D square is equal to minus A square again in that place? So in that cases, you have to use the rationalization and then reduce into the terms of again into the D square and substitute d square is equal to minus a square. Suppose if it is the 0, so the second f dash of minus a square is equal to 0, you can write that as x square by 2 into 1 by f double dash of d square into sine ax. So this is the rule 2. And now the rule 3. So rule 3 is q of x is equal to polynomial. So polynomial. So how can we find out the particular integral when q of x is equal to x to the power k? So 1 by f of d into x to the power k. So this one you can write f of d. This one you can write it as 1 plus phi of d. So 1 by 1 plus or minus phi of d into x to the power k, or a polynomial. So now this denominator you can write in the numerator. Then how can we convert this 1 plus or minus phi of d means you have to take out the lowest degree terms. So take out the lowest degree terms as a common. So take the common, the lowest degree terms, and then convert into this form 1 plus or minus phi of d. So after that, you can write in the numerator 1 plus or minus phi of d whole to the power minus 1 into x to the power k. And now expand this 1 plus or minus phi of d by using binomial theorem or the binomial expansion. So use the binomial theorem and write down this expansion up to the terms containing d power k, and after that multiply with x to the power k with each term of this expansion. Take only up to the terms of d power k. Since d power k plus 1, k plus 2, all the terms we are neglecting, since the k plus 1th derivative of k plus 1th derivative, so capital D means the derivative, x to the power k is 0. That's what we are neglecting, the highest powers of the k plus 1, k plus 2, k plus 3 and so on. So you just take only the terms containing d power k. And then operate x to the power k on each term of this expansion. So that will give a particular solution. After getting the particular solution, you have to write the general solution finally, complementary function plus a particular integral. So both you have to write. A complementary function plus particular integral is the solution of f of d into y is equal to q of x. F of d into y is equal to q of x. And next method is a rule 4 is q of x is equal to e power ax into v. So here v is equal to polynomial or sine ax, or this is here the trigonometric function. Only here the trigonometric functions are the sine ax or the cos ax, or sine ax plus b or cos ax plus b. Then how can we find out the yp? So 1 by f of d into q of x is equal to 1 by f of d into q of x is so e power ax into v, right? So if e power first observe the given function. So if the product of the two functions are there, so in that product exponential function included, so first you use the rule 4 and after that use the another rules. Okay, don't write this as 1 by f of d into v into e power ax. So this v is either polynomial or the sine function. So this next rule 5 is the polynomial. If the polynomial is there, so don't apply the rule 5 first. Use the rule 4 first and then do the solution. So here we have to use two cases we have to use and finding the yp. So first operate e power ax on this f of d. So here the substitution is 1 by f of d plus a. Substitution of d by d plus a is the substitution. D plus a into v. Again, this is a, if it is a v is a polynomial, use the rule 3. If v is a sine function, so sine function or the cos function, use rule 2. So if it is a sine function or the cosine function, use the rule 2 and then find out this value. So if it is a polynomial, use the rule 3 and then find out this value. So that will give the yp of the given differential equation. So finally write the complete solution. So writing the complete solution, you will get the 1 mark. So y is equal to yc plus yp. Yc is the complementary function plus yp is the particular solution. So this is the rule 4. Rule 5. So rule 5 is x to the power m into v and x into v. So v is a sine function. So v is a sine function. Then if it is a sine function, how can we find the particular integral x to the power m into v is equal to? So you have to write the imaginary part. So here you have to write the imaginary part. So imaginary part of 1 by f of d into e power iax into v. Now this is reduces to the rule 4 and then find out. So if it is the cos function, real part of 1 by f of d into e power iax into v. And now use the, this is converts to the rule 4. Use the rule 4 and then find out the solution. Finally, you have to take only the real part of, in real part of 1 by f of d into e power ix into v. So then only the solution will complete it. And similarly, in this also, finally, you have to take the imaginary part of this function. So that gives the solution for a 1 by f of d into, that means v is a sine function. And next it is a x into v. So if x into v is there, so if 1 by f of d is x into v, so what is the formula here? X minus 1
X minus 1 by f of d into f dash of d
dash of d by into 1 into f of d into
v.
so this is the formula to find the particular integral when q of x is equal to x into v. So these are the different cases to find the particular solution. And next finally is the variation of parameters. That variation of parameters I'll discuss in the tomorrow class. And here how the question they will give, solve the differential equation they will mention. Okay, first see the differential equation. So whether it, if the given differential equation is the second order, so if it is a second order, so either you use the variation of parameters and these rules also you can use it. Suppose if it is a third order differential equations they have given, so if it is a third order, please don't use the variation of a parameters method. So variation of parameters, don't use the variation of parameters if it is a third order. If it is only the second order, you use the variation of parameters. Okay. So the next class we will see in the, so we'll see the next method, the variation of parameters. Already you know the variation of parameters. So how can we find the variation of parameters? Can you say what are the steps you made we did in the activity? So first we have to find the complementary function. Finding the complementary function is the same in every method. So second order, second and higher order. So what is the YP? What is the YP to find out?
Yp is minus y1 integration of y2 into g of x by w dx plus
Right.
y2 into integration y1 g of x by w dx.
Okay. So if you got any confusions in the videos of the variation of parameters, you just go through my material. In that material already the method is there. Use that method and then solve. So wait, just I'll check the attendance. 34 and 35. 37, 38 also not there. Absent. 41 absent. 46 absent.